Hey there, science fans! Today we're diving into the fascinating world of computers. These digital marvels have revolutionized our lives. From smartphones to laptops, they're everywhere. But have you ever wondered what makes them tick? Computers may seem complex, but at their core they're like helpful friends who follow our instructions. They help us write stories, play games, and connect with people all over the world. Pretty cool, right? In this journey, we'll unravel the mysteries behind these incredible machines. We'll learn about their different parts and how they work together seamlessly. So buckle up and get ready for an exciting adventure into the heart of computers. Now, let's meet the team players inside every computer, the hardware. These are the essential components that make your computer function smoothly and efficiently. Think of hardware as the physical parts of the computer, the things you can actually touch. These components work together to perform the tasks you need. First up, we have the CPU, or Central Processing Unit. This is the powerhouse of the computer. The CPU is like the brain of the computer, making decisions and running the show. It processes instructions and performs calculations at lightning speed. Next, we have RAM, or Random Access Memory. This is crucial for multitasking. RAM is the computer's short-term memory, storing information it needs quickly. It allows your computer to access data in a flash, making your experience smoother. Then there's the hard drive, the long-term memory. This is where all your important data resides. The hard drive stores all your files, pictures, and videos. It's like a digital library keeping everything safe and accessible. Finally, we have the motherboard, the central hub connecting all these parts. It's the backbone of the computer. It's like a giant circuit board that allows all the components to communicate with each other. Without it, the computer wouldn't function as a cohesive unit. Each hardware component has a specific role to play. The CPU, with its incredible processing power, handles all the calculations and instructions. It's the workhorse of the computer, constantly crunching numbers and executing commands. RAM jumps in to assist the CPU by storing data that the CPU needs frequently. This makes the computer faster because it doesn't have to wait for data from the hard drive. The hard drive is like a massive filing cabinet, storing all your important documents, music, and software. And the motherboard? It's the communication highway, ensuring that all these components can talk to each other and work in perfect harmony. Section 4. Teamwork makes the dream work. How hardware components interact. Now let's see these components in action. Imagine you're playing a game on your computer. When you click play, the CPU receives the command. It then fetches the game data from the hard drive and loads it into RAM for quick access. The CPU, using data from the RAM, then sends instructions to the graphics card to display the game on your screen. All throughout this process, the motherboard ensures smooth communication between all these components. It's like a well-choreographed dance, with each part playing its role flawlessly. Section 5. The brains of the operation software and its role. Now, you might be wondering, how does the hardware know what to do? How does it understand the tasks it needs to perform? That's where software comes in. Software acts as the intermediary between the user and the hardware. Software is a set of instructions that tells the hardware what tasks to perform. It can be as simple as a calculator app, or as complex as an operating system. Think of it as the language of computers. Just like humans use languages to communicate, computers use software to understand commands. There are different types of software, such as operating systems like Windows and macOS, which manage the hardware and software resources of the computer. And then there are applications like web browsers and games, which allow us to perform specific tasks or entertain ourselves. They all provide instructions to the hardware, dictating how it should behave. This interaction is crucial for the functionality of any computer system. Without software, hardware is just a bunch of inactive components. It's like having a car without a driver. Software breathes life into the hardware, enabling it to perform all the amazing things we use computers for. From browsing the internet to playing games, software makes it all possible. Section 6. Talking in zeros and ones, binary code and software communication. But how does software communicate with hardware? This question is at the heart of computer science and technology. This is where binary code comes in. Binary code acts as the intermediary, translating human instructions into a format that machines can understand. Binary code is a language of only 2 digits, 0 and 1. These 2 simple digits form the basis of all computer operations. Think of it as a light switch. It's either on or off, 1 or 0. This simplicity is what makes binary so powerful and efficient. Every instruction, every piece of data is converted into a series of zeros and ones. This conversion process is crucial for the functioning of all digital devices. The hardware then reads and interprets these binary codes, carrying out the instructions encoded within them. This seamless interaction between software and hardware is what powers our modern world. It's a fascinating system of communication that forms the foundation of how computers operate. Without binary code, the complex tasks we perform on computers would be impossible. So there you have it, an inside look at the world of computers. From the simplest calculations to the most complex algorithms, binary code is at the core. From the powerful CPU to the essential software, each component plays a vital role. The CPU processes the binary instructions while the software provides the commands, and at the heart of it all is the magic of binary code, allowing humans to communicate with machines in a language they understand. This universal language bridges the gap between human intention and machine execution. It's a testament to human ingenuity and a clear sign that the future of computers is only going to get brighter. As technology advances, the role of binary code will continue to be pivotal. Keep those curious minds exploring, and who knows what incredible advancements we'll make together. The journey of discovery in the realm of computing is just beginning.